afternoon to you all. Today we'll be introducing ourselves to differential calculus. So we'll be starting with the general formula method. So I want us to know the formula method before moving to differentiation from the first principle. And in the general formula method, let's assume we have x, y, a, b, n. All these should be which is the same as we have n coefficient of n serving as coefficient of x, and we have, or let's say a serving as coefficient of x, then raised to the power of n. We are differentiating with y with respect to x. That's why you see that common word in differential calculus that you see the y. Of the following. That is, you're just given 1 to find the derivative of 3x raised to power 7, 2, 2x raised to power minus 5. You are not given that you are not given that any variable is with respect to y. So this is how you write it. You say d dx of this. D dx of this will now be 7 times 3, which is 21, x raised to power 7 minus 1, 6. Second one as well, d dx, which equals minus 5 times 2, that's minus 10, x raised to power minus 5 minus 1, which equals minus 6. So that's the simple method and the simple tool which we use in differential calculus. So let us move to the addition and subtraction of differential calculus. The addition and subtraction. Now, the addition and subtraction in differential calculus is just the addition of the individual derivatives given, which is with respect to y. For instance, you can be given y equals 3x raised to power minus 4 plus 6x raised to power 2 plus 3x raised to power minus 4. Now, y with respect to x, so we have the y dx will be equals to minus 4 is the power multiplied by the coefficient of x, which is minus 12 x raised to power minus 5 plus 2 times 6, 12 x, 2 minus 1, that's 1, so we don't need to write that one. Then we have minus 4 times 3, which is minus 12. To affect the negative sign, we have minus 12 x raised to power minus 4 minus 1 will give us minus 5. So that's okay. We can have another example. To have another example, we you have y equals 7x raised to the power 4 plus minus 8x raised to the power 4 plus 5x raised to the power minus 2. Now, since it's y with respect to x, we have dy dx, which will be equals 4 times 7, 28, x raised to the power 4 minus 1, 3, minus 4 times 8, 24, x raised to the power 4 minus 1, 3. Then since we have minus, it's going to affect the sign here. That's minus 2 times 5 minus 10, x raised to the power minus 3. So you look at it, if we have the same power on the variable x, then you simplify. This is 28x raised to the power 3 minus 24x raised to the power 3. So we have 4x raised to the power 3 minus 10x raised to the power minus 3. So that's that. Now, we should note that the y dx is just a pronunciation of variable. That is, when you have variable y being a function of x, you can have you can be told to differentiate x equals 5y raised to the power minus 4. So if you are to differentiate x with respect to y, that means you are going to have what? ds dy, which will be equals minus 4 times 5. That's minus 20y. Then we have minus 4 minus 1, which is minus 5. So that is that on addition and subtraction of differentiation. So we can move to multiplication. Multiplication in differential calculus. Now when we have, for instance, we have y equals 2x raised to the power 4 multiplied by 6x raised to the power minus 3. In multiplication, we have a standard formula which is generally known when we have y equals uv. This uv, they are function of x. So we say the dy dx, when we have product, will be equals to v du dx plus u dv dx. Now, and what do we now do? Once it is multiplication, you make one. Either this should be v or this should be the u. Then you find the individual differentiation and you fix it into this formula. For instance, example, find the derivative of the example given above. Y equals 2x raised to the power 4 multiplied by 6x raised to the power minus 3. Then, from what we did here, you can say let u equals 2x raised to the power 4 and v equals 6x raised to the power minus 3. Now, before you go deeper, because these are where you are going to find the u dx and also the v dx. So you have to find the u dx first. The u dx, which will be equals 4 times 2, 8x. Then 4 minus 1 is 3. Then the v dx will be equals to minus 3 times 6. That's minus 18. X is to the power minus 3 minus 1. That's minus 4. So you already have your v, your u and v, then the u dx and the v dx. So you can now fix that into the formula. The y dx, which equals, what is our v du dx? What is our v? Our v here is 6x raised to the power minus 3 multiplied by du dx, which is 8x raised to the power 3. Then our plus. U is 2x raised to the power 4. And dv dx. So our dv dx here is minus 18x raised to the power minus 4. So with this now, we can now, the rest is mathematics. So we multiply and add if possible. So we have 6 times 8, which is 48x. Now we have minus 3, then we have 3. So minus 3 plus 3, that is from law of indices. When you have multiplication, it changes to addition. So you have minus 3 plus 3, which is 0, plus, now you have 2x raised to the power 4 into bracket minus 18x raised to the power minus 4. So you have minus 18 times 2, that's minus 36 x raised to the power 4. This 4, x raised to the power 4 multiplied by x raised to the power minus 4, that would be x raised to the power 4 minus 4. That will be x raised to the power 0. So we are going to have 48. X raised to the power 0 is 1. multiplied by 1, plus times minus, minus 36, x raised to the power 0 is what? 1. So we have, which is the same as 48 minus 36, and this will give us 12. So this that is multiplication in differential calculus. So let us take one more example. Like we can have y equals 5x raised to the power minus 6 multiplied by 3x raised to the power 3. Now, with this, we can say let u equals 5x raised to the power minus 6 and let v equals 3x raised to the power 3. Then we'll find the du dx. Du dx equals minus 30 x raised to the power minus 7. I guess you understood how we did that. That's minus 6 times 5 minus 30 x minus 6 minus 1 minus 7. So we have dv dx, which equals 9x raised to the power 2. Now, remember our formula, general formula, which is dy dx, which equals v du dx plus u dv dx, which equals, now what's our v? Our v is 3x raised to the power 3 multiplied by du dx, that's minus 30 x raised to the power minus 7 plus u 5x raised to the power minus 6. Then we have dv dx 9x raised to the power 2. So this is equal to 3 times minus 30 minus 90 x raised to the power 3 from our indices, x raised to the power 3 multiplied by x raised to the power minus 7. That's x raised to the power 3 minus 7. That's x raised to the power minus 4 plus 5 times 9. That's 45. Then we have x raised to the power minus 6 multiplied by x raised to the power 2. And that will give us x raised to the power minus 4, which equals, so we have, since the variable is having the same power, that's minus 4 and minus 4, so which means we can add this together. So minus 90 plus 45 will give us, that's minus 45 x raised to the power 4. So in our next class on differential calculus, we are going to do that of division, which we call the quotient rule, and also we also have that of power and root, which is called the chain rule, and some call it function of a function. The chain rule or function of a function. So if you have any question on this, you can comment, and I'm going to treat that. So thank you very much for your time. We meet in the next class.